So let me talk a little bit about the future. The successor to the Kepler mission has already been approved for launch in August of 2017. It's called the Transiting Exoplanet Survey Satellite, or TESS. And what TESS will do is basically, TESS will do for the whole sky what Kepler did for this one small patch of the summer Milky Way, but for brighter stars. So it will try to find, now that we know that Earth-sized planets are everywhere, very common, it will try to find the nearest examples around the brightest stars in the sky where we can actually have a hope of characterizing those planets extremely well, maybe even detecting their atmospheres. This is a full-scale model of the TESS satellite with the core science team at MIT. TESS is quite a bit smaller mission than the Kepler mission was. It's an Explorer-class mission, which is capped at a $200 million budget for hardware and launch. There are funds in the TESS mission to build this spacecraft and the instruments, to launch it and to operate it for a 2-year mission. And for limited follow-up observations from the ground to try to weed out some of the signals that could look like a transiting planet but aren't actually. They're due to something else. So at the end of the TESS mission, they will have a list of planetary systems around the brightest stars in the sky, identified and vetted to some extent, but there's no funding in the mission to do science on those targets. It's kind of ironic. They'll just release the data into a database, and they have a similar arrangement with this European team to do this stellar seismology analysis. I'm not sure how they're going to get the exoplanet analysis, I mean, just the transit analysis itself. This is one of 4 telescopes, really large cameras, that TESS will use to scan the whole sky. Each of these cameras will basically capture 6 times the size of the Kepler field, and there's 4 of them. So at any one time, it will be looking at 24 times the area of the Kepler field. And essentially what the program is to scan the sky in strips. So it will look at the northern ecliptic hemisphere in these strips, 13 strips during the first year. That will flip over and do the southern hemisphere in another 13 strips. So just a 2-year mission. The cameras are arranged so that they stack vertically like this, and the one that's at the pole more or less stays the same during each of those years. So even though each of these strips is only monitored for 27 days, that highest latitude, that ecliptic pole field, is monitored for a full year, continuous. So, right, the issue with that is that much of the sky, you'll only have 27-day time series, and so you'll only get the planets that are relatively close in and go around frequently. But at the pole, you'll discover many planets in longer orbits. We expect TESS to discover thousands of new planets, including dozens of planets that are the size, similar in size to the Earth and in the habitable zone of its star, where liquid water could potentially exist. And again, there will be a specified list of targets, 200,000 in the case of TESS. All of those targets will be monitored at that faster cadence of 1 or 2 minutes that will allow you to do stellar seismology. But the orbit of TESS actually allows for these full images to be downloaded. And so there will be a 30-minute cadence for the entire sky where you'll actually get all of those images. And so, some tens of millions of stars that you don't have to pre-select can be scanned for planets from those full images. So As I mentioned, the arrangement with this European team is the same, and they'll just release the data after each strip, in fact, into the archive at the Space Telescope Science Institute, and let people go with it. And it puts us in this bizarre situation where NASA is essentially launching a mission that, that primarily European scientists whose countries are wisely investing in science will be allowed to exploit, with no support for the U.S. Science, or no support, little support beyond the traditional programs that NASA already does. Nothing specific to this mission.